Sieve analysis is the method of particle size analysis, using which we determine the amount of particles of different sizes present in the soil sample. Sieve analysis is done for coarse-grained soils. In this method, soil is sieved through a set of sieves. Sieves are wire screens having square openings. Size of these openings gives the sieves their name, which is called sieve number. A sieve with a mesh opening of 4.75 mm is designated as 4.75 mm sieve. Similarly, a 600 micron sieve refers to a sieve which has a mesh opening of 0.6 mm. Sieve analysis itself is done in two ways: dry sieve analysis, wet sieve analysis. We take roughly 500 gram of soil sample. It should not contain any lumps into it, and if it does, then lump should be pulverized. We take its weight and say this weight as capital W. Now this sample is sieved through 4.75 mm sieve. The portion of soil which contains particle size bigger than 4.75 mm is retained on the sieve. This portion is called gravel fraction. The portion of soil which contains particle size less than 4.75 mm passed through the sieve. This portion is called sand fraction. This way, coarse-grained soils are divided into two categories. One is gravels, having grain size greater than 4.75 mm, and second one is sand, having grain size smaller than 4.75 mm. So, for sieve analysis of our sample, we need two sets of sieves, one for gravel fractions and another for sand fractions. For gravel fractions, we require sieves of sizes 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm. This set is called set of coarse sieves, as it sieves coarser part of coarse soils. Second set of sieves for sand fractions consist of sieves of sizes 2 mm, 1 mm, 600 micron, 425 micron, 212 micron, 150 micron and 75 micron. If we didn't mention, then 1 mm, that is millimeter, is equal to 1000 micrometer, which we denote as micron. So 1 mm is equal to 1000 micron. So here 600 micron is actually 0.6 mm. This set of sieves is called set of fine sieves, as it sieves finer part of coarse soils. The sieves are stacked one over the other with increasing size of their mesh openings from bottom to top, which means the sieve of the largest opening is kept at the top. The pan, which has no opening, is placed below the bottommost sieve. The soil sample is placed in the top sieve, and the lid to cover this arrangement is placed over the topmost sieve. The whole arrangement is then placed on a mechanical shaker and is shaked for 10 minutes. Then arrangement is taken out and the amount of soil retained on each sieve and pan is weighed with the accuracy of 0.1 gram. Let's say the weights retained on the sieves are W1, W2, W3, W4, W5 and W pen. Then we calculate the percentage of amount of soil retained on each sieve as a weight of retained soil on the sieve divided by the total weight of soil sample multiplied by 100. This way we know what percentage of total weight is retained on a particular sieve. Percentage weight retained on the first sieve is W1 divided by capital W multiplied by 100. Let's say these percentage as P1, P2, P3, P4, P5 and P pen. For calculation purposes and to determine some important characteristics, we also calculate two values. First one is cumulative percentage retained. Let's write our calculations in a table. Now, cumulative percentage retained of any sieve is the percentage weight retained on that sieve plus all percentage weight retained of all the sieves above it. Cumulative percentage retained is the total percentage amount of soil which could not pass the particular sieve. In other words, this percent amount of soil has grain size greater than the sieve number. So let's calculate the cumulative percentage retained for each sieve. Second value we calculate is percentage finer, using which we plot a graph called particle size distribution curve. Percentage finer, as name suggests, is the percentage amount of soil which is finer than a particular sieve. Consider any sieve from the stack. The amount of soil above this sieve is coarser, and its total weight in percentage of total soil sample weight is cumulative percentage retained on this sieve. And the amount of soil below this sieve is finer portion of the sample, which has particle size smaller than openings of the sieve. Total weight of this portion in percentage of total soil sample is percentage finer of this sieve. This can be easily calculated by simply removing cumulative percentage from the 100% of the soil sample. Now we can complete our table. The whole procedure we discussed is the dry sieve analysis. The finest sieve used in the analysis is 75 micron. If the portion passing through 75 micron sieve, which we collect in the pan, is substantial, say 5 to 10%, then wet sieve analysis is carried out. The purpose of wet sieve analysis is to remove all the particles which are finer than 75 micron particles from the sample so that we arrive at the correct sieve analysis results. The sample is first washed over the 75 micron sieve to remove the fine particles sticking to the sand particles. The wet sand retained on the 75 micron sieve is dried in an oven, and after drying, the dry sieve analysis is carried out in the usual manner.